Hello, and welcome to Chapter 2. Yes, you have now made it to the second chapter of Business Statistics, where we are now looking at starting to create different versions of data. In the next few chapters, we're going to be going over those. Chapters 2, 3, and 4 are all about describing data and learning different ways of how statistics can be produced to kind of give a visual representation of the data that we have. In this chapter, we're going to be looking at more frequency, basically number distributions. So again, we have our learning objectives. We got 4 that we're going to go through as we progress in the slides and with the practice problems. So we're going to first summarize qualitative variables with frequency and relative frequency tables. We're going to display a frequency table using a bar or pie chart. Then we're going to summarize quantitative variables with frequency and relative frequency distributions and display a frequency distribution using a histogram or frequency polygon. How many times can I say frequency in just a short amount of span? If anything, if you ever seen the Dennis Quaid movie Frequency, it's a good movie. Anyway, at least a decent movie. So let's start off. What is a frequency table? Okay, so this is the basis of our data. It is a group of qualitative data into manually exclusive. Basically, data fits in just one class, and collective exhaustive classes, where there's a class for each value. That's all it is that it fits in one and that there is a class for each value, showing the numbers of observations in each class. So we're going to use the example of a vehicle dealership, basically, and how much cars that they sold each month. And right now we're in the basic model. Here we have Applewood Auto Group, and we got them grouped by location. And we can physically view that they have sold these many cars per location. We're not diving too deep into it. We just want to know how many cars they sold. So we know over, I guess we're going to say a month, they sold 180 vehicles in the 4 locations. And we can obviously see with the data that Kane did well. They sold 52. They're the highest. Well, as you heard dings from emails, because those always happen. It happens. We're going to dive deeper into this. We're going to look at basically how can we graph it and to show who will be looking at a better view and an easier way to interpret the data. This can be used for any sorts of data that we have. So right now when you're trying to think, well, what did we mean by class? Again, data fits in one mutually. Class right now is our location. It's what we're actually trying to put the numbers to. So again, there is value, which is the number of cars, and we have a class that is associated to them. And then it goes into how do we construct. So, big old sign comes up, says under construction, and we build. And what we build is, again, first sort the data into classes, which is, for our example, is the locations, count the number in each class, and report at the class frequency. which is right now the number of cars. Now we're going to convert each frequency to its relative frequency, which basically means the percentage of the whole. Now, this will be the total, so the 180, and we're going to divide all those numbers by our total. So the observations that we've seen are the data for that class. So for like Kane, we'll take 52 and divide by 180, which was the total. And its relative frequency is 0.289. Then we have the same thing for Olin, Sheffield, and Tyonostia. I don't even know how to pronounce that. Tanya, it's okay. It's an example. But we do see here, we even can see percentage-wise, which one is the greater one. Again, will be Kane, which makes sense because there are the greater number of cars sold. So they come in about 29% of the whole, the pie chart of itself. And this would be to help properly make estimates. We can actually multiply, I guess, like if somehow we sold 300 cars, and we want to see, just judging by the relative frequency, how much they would actually sell. So again, we would probably have Kane as higher since it has the higher percentage. Now, graphing it. Okay, these are really items that we need to keep an eye on. There are different graphs out there and lots of ways to give visual representation. Sometimes for here in business world, investors, our employees, or even the CEO, visual is always better than giving them a bunch of numbers. If you see a graph, you can immediately tell which location sold the most vehicles. It's very obvious. And then you're going to be questioning, why do they sell the most and how can we replicate it in the other locations? So when we look at a bar chart, again, the qualitative classes are going to show up on the X or the horizontal axis. And the class frequency will show up on the vertical axis or y-axis. Okay. And we make sure we do line it up to the number of vehicles or the observations that we saw. Notice that they also are spread out. That is a big thing that we have to keep an eye on, especially when we get into histograms. Histograms are just a little bit different. And when we look at a pie chart, we can actually make it proportional. Now this is, again, a good visual representation. If we did a pie chart with this, again, we'll show Kane has the biggest pie, or biggest piece. We can also do this as a combine of the locations. If we actually did dive deeper and looked at how many cars each location sold for whichever location this is, this can actually tell us right now that we sold, the most in sedans. Or actually, it was supposed to be SUVs, but that does not look like it's big enough. Or is it? I think they actually did not percentage. Okay, they're doing outside with 25%, 50%. That's unique. The graph isn't the greatest. I will say that. But we can obviously see sedan is the biggest piece, with hybrid being the lowest. And we definitely know if this was Texas, that truck would be a lot bigger. But then again, we also know the way that the auto industry is going. there's going to be a lot more hybrids out there as well. So these are going to change. Always will. But it's a good way to see, one, if this was the biggest earner, Kane, that we know definitely focus on sedans. Apparently that's the most popular vehicle next to SUVs that we can sell. Are they making the most profit? We would have to check in on that. And we can run another class who's making the most profit. Can happen there too. Because it may actually be like sedans may be selling the most, but we're actually making the most profit off the hybrids. So we may want to focus on selling more hybrids. So there's a lot of what-if scenarios. I'll always tell you that. That's the one fun thing about business and business decisions. You never know how it's going to end up. You got to make sure all the possibilities. That's why we do have statistics, to try to estimate the best outcome. Alright. So, frequency distribution. Now, this is grouping of quantitative data into mutual exclusive and collective exhaustive classes, showing the number of observations in each class. Basically, it's us converting quantitative, non-numeric, into almost a numeric form, okay, to actually show what's going on, how is it being interpreted. So, this is usually a 4-step process. Yes, we love our steps. Gotta get the step counter in. So we're doing it now. Let's do it. First step, we're going to decide on the number of classes. This is going to be a simple way. You're going to see, and it's fun. Number 2, we're going to determine the class interval. Quick formula on that. Also, very simple. 3. Numeral 3. Set the individual class limits. And then number 4. We're going to tally the data into classes and determine the number of the observations in each class. I'm basically going to show you how to do this in Excel, because you're going to be doing it in your homework anyway, so might as well show you how to make it a little bit easier in Excel. Okay? Well, we're going to go step by step. We're going to show you how it's actually done, and then we're going to go through how Excel can help speed up the process. Because again, in this course, Excel is probably going to be your best friend. It's my best friend. Doo-doo. Alright, so step number 1. We're going to decide the number of classes. Now, the way to do this is we're going to use what is called the 2 to the k is greater than n rule, where n is the total number of values that we have in our data set. K is going to be the number of classes. So basically, we want to go with k, or 2 to the power of, until it actually puts this formula as true. That it is greater than, not equal to, but greater than our total number of data set. So, total number of values in the data set. So, for Applewood, they have 180. So, n would equal 180. So, we got to see when is 2 to the power of what is greater than 180. If you keep going, if you want to use a calculator, which we could, I would suggest if you're going to use the one that's with Windows to turn it to scientific, or if you have a scientific, that's awesome. In order to change it from this mode that pops up to scientific, just hit the 3 bars and then hit the scientific. This will give you that x to the y power. So you can literally go to x to the y and then type in any number. So we go 7. We know we're at 128. That's not over 180. You want to pretty much go in order. If you know 2 to the power of is close, you may want to just double check it. But as you can see, 2 to the power of 8 is 256. This is the first 2 to the power of that is greater than 180. Thus, our number of classes that we need is going to be 8. So we're going to use 8 classes. Step 2 in our handy dandy notebook is going to be determine the class interval I, which is going to be greater than or equal to this formula of taking the maximum value minus minimum value. We have to do that first. That should be in parentheses, but they don't have it. But we always do that first, and then divide by our number of classes. So in this one, if we actually went through the data set, we could actually see that 294 is our minimum and 3,292 is our maximum. Again, we can use Excel to make this a lot quicker with a huge data set. I'll show you how to sort also in Excel if you haven't done that before when we go through our examples. Well, our practice problems that seem to happen at the end of the PowerPoint. Anyway, so the interval in itself, taking the maximum minus minimum and then divide by 8, ends up being about 374.75. Now, that makes an interval a little bit too close. Again, we want the interval to be greater than or equal to it. So, we're going to try to round this off. And usually, it makes it a lot easier to round it in multiples of 10 or 100. Sometimes in 0.5 if we're really small intervals, but always greater. So decide to use an interval of 400. It's a little bit rounded, makes the life a little bit easier. The interval is also referred to as the class width. Basically, it's going to be our range. That's what it is. Alright. Step 3. Set the individual class limits. Again, lower limits should be rounded to an easy to read number when possible. We always want to keep it as simple as possible as we can and make sure it encompasses both the lower limit and the maximum limit, upper limit, sorry. Now, typically, again, we're going to do the ranges, and we can add, subtract on ranges, how we want to go. Since the lowest one was 294, 200, which would be basically good, solid one that's under it, would work as a lower limit. And then add 400 for our interval. We get to 600, then 600, add 400, we get to 1,000, so forth and so on. And that's how we make our classes using that interval. Always double check that your last class encompasses that upper data set, the maximum data set, which was 3,292, and this one does. Okay. Typically, they will always have both the minimum and maximum in your minimum and maximum class sets. Alright. Next, when we're computing our data set, we now tally the number of data into the classes and determine the number of observations in each class. Again, this is if we're going to do it manually. We are going to try not to do that as much. I mean, it's good to know how to do it manually. Yay. But with these bigger sets, like 180 numbers, we're going to try and save you as much time and show you again how to put these stuff into Excel, how to do the steps in order to perform it in Excel to make it a little bit easier in observations. There's still going to be a lot of math to determine later on in this course, but with these basic ones to get you the basic understanding, we're going to try to use Excel as we go. Alright, so relative frequency distributions, again, is going to be the same pattern that we just did before. We're going to take our observations that we recognized in each of these classes, these ranges, and we're going to divide by the total, and that's going to be our relative frequency. Notice in this case, we do have what is pretty much looks like a bell curve because we're dealing with profit and selling vehicles. Again, mostly you're going to find something really good in the middle where we can sell the most vehicles at the highest profit, basically at equilibrium. It happens. This is our peak, and we like it, which is the 1800 to 2200. Woo! And we can even see this in graphical form with a histogram. Now, histograms again, because we're doing with consecutive numbers for our classes, we typically will use a histogram because it is continuous. So this is where the difference between a bar graph and a histogram is. Bar graphs are not a continuous number. They are very strict, while histograms are continuous. So all the bars will come together with no gaps. So again, we put the class frequencies on the y-axis, vertical axis, and the frequencies are represented by heights of bars, and the bars are drawn adjacent. Horizontal axis is the classes again. Basically all that is going on with the histogram. Another way that we can visually see what's happening with these ranges. Now there's another frequency distribution, and this is known as a frequency polygon. Okay? It's a different shape already. This looks more like a mountain. It is a line chart, but instead of using the n numbers, notice that it's not using the n numbers like down here in profit. It is using the midpoints. Okay? Basically the number right in between each of our ranges. Since we got interval 400, divide by 2, that's a 200 right there. So we would add 200 to each of the lowest limits. That would be the quickest way to get to the midpoint of each of your classes. Which again, they have it calculated right here for you with the frequency, and then they plot. So, again, midpoints are going to be on our x-axis, our horizontal, while frequency is on our vertical. And we just blink, 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 yay! And we connect the dots. Alright, so next we would have cumulative frequency distributions. This is mostly when we want to see a total of less than the amount or item that we're looking at. So it's like, who sold less than 20 cars? Well, we can see with all of our classes. Again, so popular. So, With that being said, the quick way that we see that goes on is that less than 600, that was 8. That's going to change. When we look at less than 1,000, we have the 200 to 400 range, or 200 to 600 range, sorry. That was 8, plus the 600 to 1,000 range, which was 19. Oh, by the way, when we count, we do, it hits like one of the limits, like the upper limit. Like if we have a car that we sold for 600 or had profit of 600. If we had a profit of 600, it would go into the 600 to 1,000 class, then the 200 to 600. It always goes to the upper class. Okay? Let's hopefully we don't have any more notifications of emails. Yay! I know that those dings are probably going to go, Alright. So once we have that, we again do the 180. And as you can see, our percentage should increase starting from the first class to the second. Notice the increase until we finish with our 8th class, or our last class, which should be 100%. Because it should equal the total that we have actually worked in the data set. Okay. Alright. The other way we can graph this, again, is in our little line chart that we have here. Our frequency polygon chart. And this one is one that helps us with observations and a lot of times estimates. Again, using the data set that we have right now. Notice that it will start from the bottom, the lowest value, and it will go all the way to the upper limits of each one. Basically, that's what our less than was. And it would naturally increase up until we hit 100. But here we can question. So here we got the number of vehicles sold. We have the profit and the percentage of vehicles sold. So if I want to look for a certain percentage, like 75%, when I hit 75%, how much profit should I be making? How many vehicles should I have sold? Well, right here, we can see it's probably a little bit about 135. Looks like right here. Notice that there's no dot. It just hits the line. So about 135 cars should be sold at 75%. And we should be making a profit probably right around 2,300. Because that doesn't look like halfway between the two. So, again, we can do that. We can go, okay, if I want to make, looks like $2,000 worth of profit, which is halfway between these two. I can look up. I should be selling about 100 vehicles. So that should be a little bit over 50%. Looks close to like 55%. And they give another example right there. Again, just reading the chart. So if you're having difficulties with these, please let me know. Send me those questions. Okay? Send me those. I will help you through this. Because it's only going to get a tad bit more complicated as we move forward. Again, it's very commutative that way. Alright. So, that's chapter 2 in a nutshell. That's it. So we're going to go over some practice problems before you tackle on the homework, just to help y'all guys out a little bit more. And these we will show in an Excel. So, starting off first, we have Railstone Inc. They're going to produce and market replacement covers for cell phones in 5 different colors: white, black, lime, orange, and red. Okay, I just made it simple. To estimate the demand for each color, the company sets up a kiosk for several hours in the Mall of America and asks randomly selected people which cover color was their favorite. All right. So, first off, we know we have a frequency table. I don't know why they would throw in what is this table called. We're only working with one type of table right now, and it's not oak. Okay, so it wants us to draw a bar chart and a pie chart. We can easily do those for and connect. Show you those, and then they want to ask what would happen if you produce 1,000,000 of these. Okay, well, I'm going to go ahead and throw in Excel. So here's our Excel. Yay! And we're going to go ahead and put it in. Again, I'm going to keep them simple with just the basic colors. So, alright. And then, for purposes, we're going to keep the numbers next to them. Alright, so once we have these numbers, again, we need to know the total. So, easy way to do it, highlight, go here to formulas, and tell it to auto sum. So here we have 1,300, basically customers that reviewed, and that's how the numbers roll. Alright, from here, we again take the average to find the frequency percentage. So we will take it to tell it to equal wherever's in B divided by our total. And then you can basically just highlight down and we'll calculate it out. Okay? Don't tell it to go equal this square divided by this square. It won't work with that drop down. You would have to redo it every time you do it. Okay? That makes it a little bit easier. So again, we have that divided by the total. That's our percentage. Now, if this tells you to do 2 decimal places or more, again, we can always do our zeros. Apparently, if we need to. So you can always take the zeros, you can decrease zeros. That is up to y'all. Okay? Again, we'll probably do that in Excel, especially if McGraw-Hill says round to the nearest blank. Helps us out. Okay? And believe me, I'm already having some issues with Connect and the wording of how they say things. It's crazy. Anyway, this is our relative frequency. And in order to find basically the answer to D, we would take this frequency and multiply it by 1,000,000. Because again, it's an estimate. So there's our numbers. Again, if you ever want to double check, you can highlight, hit formula, tell it to auto sum. And if it comes out to 1,000,000, we're good. If you want all the commas, we can actually put all the commas in. I typically will go accounting, then we can change it. More accounting features, take away the dollar, and no decimal places. Boom. There you go. To make it a little bit easier to see with commas. Sometimes that works. But this will actually tell us based on the data and the surveys that we got. If we were trying to produce 1,000,000 cell phone covers, these would be the ones that we would produce of each color because that is the proportion as we go. Now, your book somehow has a different numbers. They just basically added 3 zeros to all numbers for 1 million, which I guess does add up to 1 million, but is not correct. Okay, that is not correct. That is a big mistake. I wonder if it actually does. It should, because this is the numbers that they come up with. 30. And 286. So basically, they only multiply it by, looks like 1,000, something around there. Oh. Sorry. Which, again, if they're selling 1 million, look at this. If I'm trying to sell 1 million cell phones, and I use their numbers, that said I actually sold 1,030,000 or 300,000. 300? Yeah, that's 1,300,000 cell phones. It's off by 300,000. Yeah, so their numbers are definitely off. Somebody just multiplied whatever the number is by 1,000, it looks like. So, again, sometimes the book is correct, sometimes it's wrong. Nobody was proofreading and checking the math. So if you do run into a math issue, like with the homework or something like that, especially since we're using algorithmic problems, let me know. I have no problems with going back through your problem and checking the math to see if they did make a mistake like they have in the notes. It happens. But let's say if you want to do on Excel a pie chart or a bar graph. First off, make sure you highlight the data set, and then you can go to Insert, and you're going to see right here in this middle, Charts. Basically, that's what it is, Charts. And right here is going to be your bar chart. Now, I typically like 3D charts. I don't know why. I just like it with pop. But we can actually have it here. And if we want to add, we can add labels. We can change the style up if we want to. And we can even filter the results if we want to eliminate some. Okay? That's one way. If you want to do the pie chart, again, make sure you click off of the bar. We can do the pie chart. Again, you can have it like this. Oh, bigger. Let's move it down here so you can see it. So right here, pie chart, again, I can do a lot of different items. I can label. I can edit the styles. Again, I can change the colors. I can change the names. Here, we can actually put data labels. We can click on the arrow. We can actually change where we see them. Go more options. You can tell it to be a percentage. We don't need the value, just the percentage as itself. And tell it to go outside. Look at that. There's our pie chart. And we can edit, we can delete. the titles if we don't want the titles. Okay, there's lots of ways. I would say experiment. If you haven't messed with a graph before on here, experiment. They're fun to do. We could do a histogram, but really, I mean, with the data set that we have, and Excel needs more work with histograms. They're not really always that more visual appearing, but we can do it. So that's just the basics of putting in a graph. If you've never done it before, like I said, experiment. It's fun. All right. So next, we have question 11, which says, Waukesha Manufacturing Inc. produced the following number of units in the last 16 days. And it gives us a data set. And then it wants to answer all these information. So first off, let's get these numbers in our Excel because we don't have the file. So I'm going to add a sheet just because I'm going to put them all together. And we have 27, 27, 27, 28, 27. All right. So right here we have a quantitative. These don't have a class yet to them. We're going to make a class. Okay? Now, first thing it does ask is how many classes should we have? Well, we need to know how many numbers. Well, if you didn't start with 1, because this shows us 16 already, but if you didn't have to start with 1, you can actually highlight, and then if you go to the bottom of the Excel sheet, usually it's going to provide information, count how many cells are selected. So if we just select the numbers, it will count for us there too. It will also have the sum, if we were looking for the sum, or even the average. That's nice and dandy. But we know we got 16 numbers to work with. Remember, the formula was 2 to the power of k, which is the classes, greater than n, our number of data, our value in our data sets, number of values. Now, since we're at 16, if I just had to tell you, figure out how many classes, you can go using calculator 2 to the power of and go 1, 2, 3, 4, 5 until you're greater. Be careful, because since 2 to the power of 4 is 16, and that's the number of data points, values. Sorry, I typically end up using different terminology, but anyway, the number of values. We cannot use it because it is equal. Okay? We're looking only at the first one that is greater than. So that would definitely mean 2 to the power of 5 will be our class. So we're going to have 5 classes. Let's go ahead and mark that. So 5 classes. Okay? Next question. It's going to ask, what class interval would you suggest? Okay. So again, we're going to use our formula, but we need to know the maximum and minimum. Now with 16, it's probably easier to see, but for I'm in Excel, here's a quick way. Highlight your numbers, go to data, and then to sort, and tell it to go smallest to largest. You can tell it to go largest to smallest, whichever way you want to. Typically do smallest to largest if I'm sorting, and hit OK. Now it has sorted all your values into the proper range. I know which is greater and which one's less. Now, if you have actual data, frequency classes, you can actually still sort it. Just make sure you highlight both columns. But I'm showing you how to do that class a little bit different. Okay? Using famous pivot tables. Yes. So here, remember in parentheses, equal. We're going to let Excel do our formula for us. Right now it has a frowny face because it's got to work. Oh, well, let's work. So we're going to take the maximum number, which was 31. It's the one that's here on the bottom. Minus the minimum number, which is 25. And then divide it by our classes, which we figured out is going to be 5. Now we're sitting at 1.2. Okay? That's fine and dandy. I has to be greater than or equal to 1.2. It's not the easiest number to work with when we want to do classes. Again, we want that kind of rounded number. So when we're dealing with a decimal, and again, lower numbers, probably going to round it to the nearest like halfway point, which would be 1.5. So we're going to make the interval 1.5. Again, it's greater than 1.2. Makes life a little bit easier. Now, what is the lower limit would you recommend for the first class? That's going to be C. Well, since we're sitting at 1.5, it's going to be a lot easier, again, to kind of round a little bit down from our lower limit, which will be probably about 24. Can we do 23.5? No, because 23.5 will equal to 25. And that would mean our lower limit got pushed out into the next class, which we can't do. So we do have to encompass it into it. So giving us 24 basically gives us a range for our first class to 25.5. Okay? And then again, you would add 1.5 to each number after. So 25.5 then will equal to 27. Then 27 to 28.5. Then adding another 1.5 will get us to 30. And then 30 to 31.5. Now, there's two ways of thought of going through with this. Again, is basically either you start with the upper limit, go a little bit higher than that, and then subtract down until you get 5 classes and see if it takes the lower limit. But usually you just want where that in the lower limit range or lower class has your minimum value. It takes a little bit. That's why we got practices. Yes. Alright. So, this is our limit, our classes, and then we can count if we want to see what we got. So 2, 4, 8, 0, 2. So this would have been if we counted how many numbers are in each. Again, we're dealing with the lower data set. Makes it life easy. Again, with this one, our frequency. So, again, our frequency right here. Hover over it, highlight it if you're using Excel. Make sure that the sum is the same amount as the many data sets that we have, values that we have in our data set. So if we have 16, they should add up to 16. Okay. Nice. And again, we can already state that from 27 to 28.5, that is going to be our highest point. and that's going to be our largest concentration. Okay. Now, let's say if you want to do this, use Excel, not type out, then want to count. All right. In order to do so, we're going to use a pivot table. So again, highlight your numbers. Then we're going to go Insert, Pivot Table. Okay. It's going to have it all selected. Typically, we don't have to highlight it. We can just hit Insert Pivot Table, but because I have all these extra numbers, we'll try to highlight all that. It's okay. So hit OK. It's going to pop up a new sheet. Right now, it has all the data that we just used. What we want to do is move it to rows. Take it, highlight, keep it hold, so you can drag, and then move it to values. Okay. Here, as you can start to see, looks very similar to our frequency table right here already. Except we don't want to know the sum. Sum's fine. We want to know the count. So in order to do the count, we're going to click. We're going to right click on one of the cells and tell it to summarize value by count. Alright, so it looks kind of different because it's got 1, 2, 3, 4, 5, 6 classes. It doesn't have 5. We have to get it to 5. So here, make sure you got one of the cells under rows labeled, highlight, click, and hit group. Okay. Once we have group, we're going to tell it to go by 1.5 with a starting value at 24.5. Not 24.5, 24, sorry. I was thinking the 0.5 already for our 31.5. Okay. Again, I type in the higher or upper. I can leave this blank if I wanted to. And see, if you left it blank, nothing. We can't tell it to end it at 31 because that would not have all the data. So hit OK. And there's our small little table pivot. Since that is 0 in one of our classes, notice it's skipping. It doesn't have it, so it only has 4. Because again, ours, there was nothing between 28.5 and 30. So thus, it didn't show it. Okay. That's the one thing that ends up happening if there's 0 numbers. We have to double make sure that we have the gap. Okay, know what the gap is. All right. Hopefully that helped a little bit. Let's try again. Okay. So here, question 17. Our last practice problem is using the following frequency distribution reports. The number of frequency flyer miles reported in the thousands for employees of Brumley Statistical Consultants Inc. during the most recent quarter. Again, if you haven't done it already, make sure you pause on these slides, try and answer them first, and then see if you did it right to get on that extra practice. Alright. Anyway, starting off first, A. How many employees were studied? Well, that's really just looking at the total. And we find out that 50 were. Okay, life's easy. What is the midpoint of the first class? Okay, we want to find what's in the middle. Well, if we know 0 to 3, 3 to 6, we're looking at a 3 as the midpoint. Well, not the midpoint. 3 as the interval, sorry. So, if 3 is the interval, we would basically divide that by 2 which would state 1.5. And then we would add it to the lower limit on each of these ranges. With 0 plus 1.5, our midpoint would be 1.5. What lower limit would you recommend for the first class? What? Okay, so when they're talking about this, since they're looking at midpoint and they're doing a continuous, it's like a polygon, frequency polygon, I think basically they're trying to tell you to just use 1,500 miles, 1.5. But if we really look at that the way that it's stated, 0 will be the recommend for the first class. That's a little bit odd of how they have that second part of that question. Next, we would construct a histogram. Now, if you come across a workout problem that says, please, outside of Connect, create a graph, you do not have to turn those in. That's fine. If you want to turn them in, you can. I have no problems of those. Just showing how well you're learning it from beyond the grave. What I want to tell you, this is, again, in the graph itself. If I wanted to try to do a histogram on Excel, it tries to keep it in order, which I don't like. But remember, a histogram is a bar graph that's just continuous. Alright, so again, I would just draw the bar graph, put all the bars next to each other, and show from this range 5, this range 12, so forth and so on. D's going to say a frequency polygon is to be drawn. What are the coordinates of the plot of the first class? Okay, so again, the plot, when we look at a frequency polygon, is always X is the midpoint, Y is going to be the frequency, which for us is the number of employees. So from here, our midpoint is the 1.5, so that would be X, first number. Second number would have been 5, or Y. Okay, and then they want you to construct one, which you can later on. Okay, if we really want to interpret the frequent file miles as we go, since this is commutative, also watch out for that. It's commutative. We can find that if we want to, about half of the employees that we have, half of the 50, probably flew between 6,000 and 9,000 miles. Okay, 23 right there. Half of them did that. We can also say 5 more employees, or 5 employees travel less than 3,000, because there's our less than. And some travel more than 12,000 with 2. I mean, again, it's just interpreting data. And that's it for Chapter 2. It's completely done. So again, if you have any questions, please let me know. If you want me to change my voice and try not to say so monotone and robotic, we can also work on that. Again, I always appreciate the feedback. Okay? Let me know if you have any questions, and I will see y'all next time.